not early, but we didn't get to finish what I wanted to show you tonight in class. So I just want to quickly review how to graph our sequence and our cumulative sequence in GeoGebra. So this is the sequence 1, 1, 2. And we want to look at how we can graph term number and sequence. So term number will be our x-axis, sequence will be our y-axis, our y values. You can think about these as ordered pairs, like 1, 1, 2, 3, 3, 5, 4, 7, and so on. And then also how we graph this cumulative sequence that's just summing up our sequence. So remember, we're starting here with 1, 1, 2, and then there was one problem at the end that we didn't get to talk about, and there's a homework question on it, so I wanted to show you how to do that before you do that homework problem. Okay, so just a quick review. If I want to graph these, I highlight the two columns, and then under here I go under the Create List menu. On the drop down I have Create Polyline. It's going to name it A, and I'm fine with that, so I just hit Create, and there it is. Remember, if I click into the graphics area, that's where I can change this. I only go to 31, so I can just grab on the x-axis and pull this out a ways here so we can see all of the x-axis. I have the y-axis already scaled up to like 900 because you can see my cumulative sequence is going to go up to 961. Alright, so to get the cumulative sequence graphed, I still want the term numbers because those are going to be my x values, but then I want to select the cumulative sequence. So first I come here, drag down to select 1 through 31 of the term numbers, and then come over to the C column. I'm going to just hit Command on the Mac, I think it's Control if you have a PC, drag down until both of them are selected. And then there was an issue that I saw a couple people, I noticed this as well, a couple other people had this issue, but this is already at Create a Polyline. So that's one thing to notice with GeoGebra. When you choose something from the drop down menu, it'll stay on that tool until you change it to something else. So it has certain defaults if you haven't done anything, but once you select a tool from the drop down menu, it'll stay there. And I think for whatever reason this was acting a little bit funky. If I clicked that, it shows up and then it disappears. And I don't know why it did that, but then I'm just going to come back to here and hit Create Polyline again, and then it seems to work. So we see all those points. I'm going to hit Create, and it connects them. And we can see that while the sequence looks linear, my cumulative sequence looks more curved, almost like perhaps a quadratic. I'm not saying it is quadratic. I'm just saying it kind of looks more like a parabola or some kind of a. Obviously, the point is, for a line, we know we're going to be increasing by a constant amount, and since this is an arithmetic sequence, it makes sense that its graph would look like a line because it would have a slope of 2. It's going by up every time x goes up by 1, y goes up by 2. All right, so that makes sense from what we know about algebra, that would create a line. All right, so I'm going to rescale this a little bit. And I want to show the one example that we didn't do in class. And so if I go back to the PowerPoint real quick, this was the slide that we didn't get to talk about. Change the sequence to 3, -1, 3, and explain why the triple results in a zigzag for the sequence and a staircase for the cumulative sequence. So let's go up here. We'll change this to 3, -1, 3. Okay, so we don't really see the staircase, the zigzag on the staircase right now because of my scaling. You can see if I go to the bottom here, the sequence ends at 3 and the cumulative sequence ends at 48. So my scaling isn't very good to see that because it's going up to 900. So since this ends at 48, let's maybe bring it up to 50, the top of our y-axis. That should give us a better view of what we mean by a zigzag and a staircase. So here's the zigzag. It just goes up and down, up and down, up and down. You can see that in the sequence. It's because it's just going 3, 0, 3, 0, 3, 0, 3, 0, and so on. So that's exactly what's graphed here. Now for the cumulative sequence, notice it's going to start at 3. We're going to add 0 so it'll stay at 3. Then we'll add 3 to get to 6, add 0 to get to 6, add 3 to get to 9, add 0 to stay at 9, add 3 to get to 12, and so on. All right. So that's where you see the sequence, or the staircase, is that it stays on the same value twice in a row, and then it jumps up. So it's going to be 3, 3, and then it's going to be 6, 6, 9, 9, 12, 12, 15, 15, and so on. So what question 22 is asking you to think about this relationship between the zigzag and the staircase. Like for example, one of the questions I believe is can you create a decreasing staircase? Can you have a zigzag without a staircase, or a staircase without a zigzag? In other words, is every sequence that looks like a zigzag, does that always result in a staircase? On the flip side, for the cumulative sequence. On the flip side, if you have a cumulative sequence that looks like a staircase, do you have to have a zigzag for the sequence? So those are two of the questions. And the other one is, can you create a decreasing staircase? So those, but until we hadn't really talked about this zigzag staircase thing yet in class. So I just wanted to go through this one example and make sure you understood that example, so that you could understand. And this is, I believe, is Q22 in the homework. That's going to ask you to think about. It's basically asking you to think about the relationship between the sequence and the cumulative sequence in terms of the graphs. So we're basically graphing the sequences here. Okay, well, you can always email me or come to my office hours if you have any questions, but hopefully that should give you enough to be able to at least get started on Q22.